Hi, I'm Joe Leinhardt at the Jackson Area Career Center. Today we're going to be going over using a user frame and setting it up on a Fanuc robot. And why we're actually going to set up a user frame is so that we can teach a position on a fixture, or it's primarily used for points on a fixture that may be shifted or moved, or if they're on a odd angle or direction compared to the world location. And so what we're going to be using is this point, or this graph right here, and we're going to be using this corner as our origin, and we're going to be finding our x location, or x direction, and our y direction. So, how we're going to be doing this is we're going to be showing to set up the user frame using the 3-point method. So in setting that up, let's go ahead and show how the world frame actually interacts with this plane at the moment, and then we'll teach it the user frame, and then we'll show how the difference between the user frame and the world frame actually interact. Alright, so what we're going to do is bring our robot into world frame, and we'll come down and try to get into that position. And it is a little bit awkward because the world moves in a very different format. Everything is square to the world versus relationship to that angle that this graph plate is on. So it is very difficult to get it in there because of the world frame wanting to move straight away from the robot, or across it, or straight up and down, which is not in relationship to this plane. If we go ahead and set up a user frame though for this, all the points that we're going to use that are taught in user frame will actually be held within that location in relationship to our user frame, into that location here. First of all, we're going to press menus, cursor down to setup, come over to number 4, frames, enter, and what we're going to do is we're going to create our first point, which is our origin position, or our origin point. That's going to be the first point that our x and y locations are going to be offset or in relationship to. And one little tip is it may be easier to actually use the tool. It will help a little bit as far as how that's set up. And we've gone over how to set up the tool frame in a different video. So first of all, I'm going to try to get this point, my origin point, perpendicular to my plate and very close to that corner. Right? And what I'm going to do is push shift and record for that first position. Cursor down to my x, and I'm going to jog the machine in the x direction. And I want it to at least go 3 inches. The farther I can go out, the better it is. I like to get at least 6 inches away. And I want my end point to be the same distance away from my plate as my origin. So try to keep those the same distance from that. And however you have to get it up to these new locations, if you're in world or tool, it doesn't really matter. Just try to get it there no matter what. What I'm going to do is I'm going to try to get it to that corner right there, and I'm trying to have it the same distance away as my origin position. That position looks good. On the x direction, I'm going to push shift, record. Cursor down to my y. I can also push move to. If you use move to, what I would suggest is actually moving your robot and the pointer away from your plane a little bit. So move that up in the z direction, and then press shift and move to. Oops. Shift, move to, and it will bring you back to your origin position. That may save you a little bit of time. And then in the Y direction, we're going to set that up. And no matter how you got to get it there, get it so we can actually move this somewhat close to our Y position down here to this corner. And like I said before, try to make it the exact same distance away from your plane as you possibly can. That looks really good right there. We're on our Y direction. We're going to push shift and record. Okay, and now all of our new points. Now if we go to, as you see right here, we're in tool right now. We can push chord and go to the user frame. And so we can push shift record and we can actually see which user frame we're actually in. We just reset user frame number 1 and we are using user frame number 1. Now when I actually push my X and my Y, it should follow right along my new plane very, very smoothly. And as you see, I'm just using my X and Y and it is following the outline of this square quite well, because we taught that. So that's one benefit of the user frame, is you can teach it the new frame and the directions in the way that this is set up, my graph is set up. So now to show how this is going to work, we're going to actually use a program that is going to be programming these points in relationship to this setup, to the graph. We're going to actually follow this square around it. So if we go to select user frame, this is the name of the program that I've created for it. And just to save time, I've already created it with this one. But if we go in, and we go to our point number 1, or shift forward, that is that location. And if I actually push shift forward again, take a step off, it will follow this square all the way around in relationship to this. Okay, so now that we've demonstrated that it will follow that square around, now we're going to go and we're actually going to change the position of that, and we want it to, using the user frame, we want it to only reteach those directions, and it doesn't matter if I move this or I change the direction like that. The only thing that's going to matter is we teach that origin position and the direction of the X and the Y, and that will actually reteach those same points, or the numbers that are generated because of where this origin point is will automatically shift these to the new positions. That is the big benefit of using the user frame. So we're going to have to go back to the user frame, which we press menus, press 6 for setup, and we're already in the user frame. If you were not, you could go to your type, to your frames, your different style of frames. Your method, you could either do the 3-point, the 4-point, or the direct entry method. We're going to use the 3-point method. And the type of frame, is we're just going to use the user frame on here. Okay. So the first thing we're going to do is we're going to go up to our origin position, and we're going to get it there. We'll probably end up switching to tool to help us get it there a little bit quicker. We've set the tool frame up in a previous video. And all I'm doing is I'm going to try to make my tool perfectly perpendicular to the part, or to that plane. So I can manipulate it and move it around a little bit easier. Alright, and there would be a point, our origin point, just like it was in the first time we tried setting this up. I'm just going to push the shift and record. It does say new position calculated. It does have a set of numbers already populated. Don't worry about it. It's just taking those new positions into account. So as we get our way through that, that will fix everything as we keep moving. Alright, so now we're going to cursor down to our X position. We're going to move in the X direction, however we need to get there. We're going to move along that plane until I get to the end of this X line and define the X direction for our user frame.
And like I said, try to keep your points about the same height as each other. That will help out later on.
Alright, that looks good. So I'm going to record over my X, and now I'm going to move for my Y direction. And that looks pretty good. And looks good for the height. I'm just going to push shift and record for my Y, and now my new position has been set up. Now I'm going to go back to my program, the user frame 1, enter, and all I'm going to do is just push shift forward and watch it run and see if my points that were saved in user frame are still the exact same. It should go ahead and run the exact same way as you've seen it before, just in the new position. And as you can see, I did not go back and touch up these points. This is just because I changed the location of the origin and shown it the new direction for the X and the Y on the user frame. And it seems to be doing a really good job of following that square still. So if you were to ever use this for a new fixture or anything like that, and it ever had to be shifted, that could be shifted, and your points would stay in relationship to that as long as they were recorded in user frame 1 through 9. So which one you recorded them in, that user frame has to be set up for that. Alright, thank you.